Hello and welcome to Hacker Heap. In this video, we'll solve the problem finding the duplicate number. Before we start, please do like and subscribe to the channel Hacker Heap. So let's look into the problem. Given an array numbers containing n plus 1 integers where each integer is between 1 and n inclusive, prove that at least one duplicate number exists. Assume that there is only one duplicate number, find the duplicate one. If the given array is 1, 3, 4, 2, 2, we need to return 2 because the duplicate number is 2. Let's say if the given array is 2, 2, 2, 2, 2, and it can be, we need to return 2. If the array is 3, 1, 3, 4, 2, as said, we need to return 3. But the condition here is you must not modify the array. You must only use constant space. Your runtime complexity should be less than order of n square. There is only one duplicate number in the array, but it could be repeated more than once, like in this case. So generally, these kind of problems, you can sort it out simply. Like you can do a sort, which would become this, and then you can just traverse through, and when you find a duplicate, you can return that number. But the problem is here, for sorting, it will take n log n, and the other condition is you are not supposed to modify the array. So we are modifying the array. So the solution will be accepted, but you are not meeting the conditions here. So how can we do that? So for this, we'll go ahead and take a two-pointer approach. Let's say for the given problem 1, 3, 4, 2, 2, we can take two pointers, slow and fast, and we can increment slow by 1 index and fast by fast. Until both are the same. What I meant is we will start here, like let's say initially slow is 0 and fast is 0. Now while slow not equal to fast, all we can do is slow is equal to nums of slow, and for fast, instead of nums of fast, what we can do is nums of fast, so that we are actually, let's say if the array is 3, 1, 4, 2, 2, we can immediately jump to here instead of going one by one. So let's look into this array. So the slow is here and the fast would be nums of 3, which is 0, 1, 2, 3, which is here. The fast would be here. Now again, in the second iteration, the slow will be nums of slow, which is again 2, and the fast would be nums of 2, which is 4. Then we will go for 4, which is 2, and here we will go for 2, which is 4, and here 2, which will come back to 2, 2, and finally we will end up with 2. When we find, finally we will end up with 4 when both fast and slow are at 4. Once we are out of loop, we will go through head, and what we'll do this time is we will have a find is equal to 0 and the slow which we already have, and find not equal to slow we will do there. So once all we are doing is we are traversing from 0 to n, and since the slow is somewhere in the middle, we will try to get that, and once we are done with it, when find is equal to slow, we could return the find. That's all we need to do. Let's go ahead and code this out. As I said, we will go ahead and initialize int slow is equal to 0, int fast is equal to 0. All we need to do is while slow not equal to fast, slow is equal to nums of slow, and fast is equal to nums of fast. Once we are done, we'll do int find is equal to 0 while find not equal to slow. This time, instead of doing this, I want to do nums of fast. So find is equal to nums of find, and slow is equal to nums of slow. That's all we need to do, and all we need to do is return find. Let's see what happened here. Okay, so what happened here is since I write slow not equal to false, initially when starting itself the slow is not equal to fast. So I will go ahead and change it to do while instead of a while loop so that it does properly. So do while. So let's run this. It worked. So what happened really here is for the given array 1 3 4 1 3 2 4 2, for this array initially slow is equal to 0, fast is equal to 0, and initially we will do slow is equal to nums of 0, which is 1, and fast is equal to nums of 1, which is 3 in this case. Now again slow is equal to nums of 1, which is 3, and nums of fast, so at third index 1 0 1 2 3, nums of 4, which is 2. Now again it's nums of 3, which is 4, and here nums of 2. Nums of 2 is this, and nums of 2 is again 2. Now when we get here, it would be nums of 4, which is 2, and again it's nums of 2, which is 2. So we end up with 2. Now find is equal to 0, and we got the slow as 2. Now what we will do is find is equal to 1 in the first iteration, and slow is equal to 0 1 2, which is 2, and again find is equal to 1, which is 3, and 2 is still 2, and we'll go ahead and do find of 3, which is 4, and it will be 2, and 4 it's 2. Now both are same. We will return find, which is 2 in this case. I hope it's clear. Please do like and subscribe to the channel Hacker Keep. Thank you for watching.